One of the reasons why Flutter's hot reload is extremely powerful is because it is stateful in nature, which means that no matter how many changes you make to the app before hot reloading, it retains its state. As an example, we tap the floating action button 5 times to increase its count from 10 to 15, and then we make a few more changes to our app. On hitting hot reload, we notice that the app retains the count of 15 for the counter variable instead of being reset to 0. This means that the app isn't restarted and implies that it keeps a hold of the current state of the app no matter how many changes are made to it otherwise. This helps in cases where you are 5 or 6 screens deep inside your app and you are debugging something there. If you make any changes, you wouldn't be forced to the first screen of the app. You would stay on the screen you were on and it would immediately reflect the latest changes there. At this point, our app does exactly what the default app does, but we can make some changes to our code to improve it and make it the same as the code from the default app. In the default app, the title for the app bar is provided by the My App widget instead of it residing in the text widget directly. Hence, let's move the title of the My App widget and pass it to our My Homepage widget as an argument. Now, to receive the string as an argument, we need to create a constructor for the My Homepage class that takes in a string. Let's call this string title and initialize it in the constructor directly using the this keyword. Notice that the title field here is marked as final. As discussed in an earlier lesson, the widget class itself is immutable and hence all subclasses of the widget class such as a stateful widget, which in our case is the My Homepage widget, should be immutable as well. This class holds the values such as title provided by the parent and used by the build method of the state. Hence, all fields inside it must be immutable as well, and hence they should be marked as final. All mutable fields should lie inside the state object associated with the stateful widget, which in our case is the My Homepage state class. To access this title inside the text widget, we can use widget.title. The keyword widget here points to the My Homepage stateful widget. To confirm that it still works, let's quickly test our app bar with a different title. The default app marks the arguments to the My Homepage constructor as optional, which we can do by putting the arguments inside the curly braces to denote that they are optional. Next, the default app uses a key as one of the arguments of this constructor, which is then also passed to its super or parent class using the super keyword by using its optional key parameter. The parent class in this case being the stateful widget class. Finally, since the title argument is now optional, we need to add the name of the optional parameter in the constructor before providing the value. A quick test with hot reload confirms that our code still behaves the same. To keep it simple for now, think of a key as a unique identifier for a widget, just like IDs for views in native Android development. But in reality, a key can be used for a lot more, and I encourage you to check out the link in the lesson notes for further details. Also note that we simply declare the key in the constructor and do not use this.key because we don't have a field that needs this value, just like in the case of the title field. We are simply passing the key forward to the super constructor. All functions in Dart that just contain one expression can be simplified to an expression syntax using the arrow shorthand. In our case, this arrow syntax replaces the return statement and its braces with the arrow operator. The same can also be done for our main method. Next, since we know the return type of the createState function, we can be more explicit with it by replacing it with the actual name of the state class, which in our case is the myHomepageState class. Next, let's move the floating action button widget to the bottom in our widget tree and reorder its parameters to model the default app. Note that doing so doesn't impact our UI in any way. Further, let's change the static text in the first text widget to be exactly the same as the default app, and then hot reload to see it get updated on the emulator. The only difference between our code and the default app code at this point is that our app uses double quotes for string literals, but the default app uses single quotes. In Dart, both of them have no difference, and hence you are free to opt for whichever you are more suited to. Finally, if we remove the extra blank line at the bottom of the code, we get the exact 63 lines that are there in the default app after removing the comments from it. Notice that if we close the app now and launch it again from the emulator, all our hot reloaded or hot restarted changes are lost. This is because both hot reload and hot restart are meant for the purpose of development only. But to retain the changes in the final Android APK or the iOS IPA file, we need to stop the current app and go for a full restart, which builds the app again. Once we go for the full restart, we see that the changes are retained even after relaunching the app from the emulator.